Hello, so I'm going to start us off here with pages 2 and 3 with some hints. First thing that you're always going to want to do is look for a greatest common factor first. That's going to save you a lot of trouble on some of these problems. And then once that's taken care of, you'll either be looking at some perfect square types, and those are the ones that have 3 terms, right, where it's always positive at the end, but we could either have a plus or a minus here in the middle. And that's going to come up with 2 different situations. You're either going to have an A plus B for both, or an A minus B. But with this being a square, where the side lengths are the same, we need both of our terms to be the same, which is why you have A plus B, or A minus B. The other type, the difference of squares, when you see 2 terms, so like an A squared minus B squared situation, your answer is always going to take the form of A plus B and A minus B. Right? Add that positive and that minus in there. All right, so let's go through and look at a couple of these here together. Alright, so if we start off here maybe with number 2, for example, I recognize this as the difference of 2 squares, right? Because I do not have 3 terms, so I'm low that my setup's going to start off looking like this. Alright, I need that positive and that negative. Now I'm just thinking, okay, what's the perfect square of 4? Well, it's 2. And I'm going to go ahead and put an m with it to get that m squared. Right, because 2m times 2m gives me 4m squared. Now, we don't have to worry about our middle terms. We know that they're canceling out because of this plus and this minus. So we're just thinking about the perfect square of the 25, which is 5. And that would be our final answer there. If you're looking at one like 11, this is where you're going to want to think about greatest common factor first. Because if you're looking at these two numbers in terms of the difference of squares, you'd be like, hey, there's not a perfect square for 98. There's not a perfect square for this 200. But when you're looking at these numbers, you may recognize I can divide both of these by a 2 as my greatest common factor. Right, here's what we would be looking like after we factor out a greatest common factor. Now you may recognize, hey, I do have a perfect square of 49. I do have a perfect square of 100. So we'll leave this greatest common factor on the outside and then factor our inside terms here. And then that would be our final answer. We have the greatest common factor on the outside. 7n times 7n gives me the 49n squared. Positive 10 and the negative 10 give me that negative 100. And then you'd also be expecting those middle terms to cancel out there. All right. So if we're looking at one like 14 here, you may see those large numbers and be like, hey, then maybe there's a greatest common factor in that. But once you try it, you'll realize that there's not, right? There's not a common factor between 100, 180, and 81. Not even 2, right? Because they're not all even. So this is one we're going to have to factor on our own here. Without the greatest common factor, shrink the numbers for us. But I've got a perfect square here in the 100. I've got a perfect square here in the 81. So we know we're going for that different, the perfect squares. And now, in terms of if I'm going to go with like an A plus B, or A minus B, it depends on this sign right here. Right? So since there's a plus sign, I know I'm going to need 2 positive terms to add up to that. Alright, and then now we're just trying to figure out the perfect squares of our 100, which is 100x squared is a 10x and a 10x. Right, and the perfect square of 81 is 9 and 9. Right, and that would be our answer there. And if you were to multiply this out, you get the 10x times the 10x, you get 100x squared. I'd have 10x times 9, which gives me 90x. Then we get another 90x. So that's where the 180x is coming from. And then 9 times 9 gives us our 81. All right? So let's switch over here to 15. Now when we look at 15, hopefully it popped right off the page there to you that we do have a greatest common factor of 10. All of these numbers are divisible by 10. Once we pull out that greatest common factor, you see the numbers get a lot easier to work with. And I see that perfect square right here. So I'm going to be able to factor that nice and easy. Recognizing I'm going to use the plus versions because I need to get a positive 10, so I'm going to need two positive terms. I kept my greatest common factor on the outside. Now I'm looking for n squared is n times n. 25 here is a 5 times a 5. So that would be our final answer there. And you could double check this if you want to. Right? That's n squared. I get a 5n. I get another 5n for the total of the 10n. 5 times 5 is 25. And if we were to multiply all that by the 10, we'd get back to our original answer. So look for the greatest common factors. Sometimes it gets a little tricky, right? Don't be afraid on ones like this to go ahead and leave them in that order, right? So for one like this, it's tempting to maybe rewrite it like this. But then it gets confusing because it doesn't look like our difference of squares, right? Because we don't have a squared minus b squared setup, right? So don't be afraid when you're looking at one like this just to factor it in this setting. Right, even though the variable's not in the front, it'll still work the same way. Perfect square of 400 is 20 and 20. And then the perfect square of 36v squared is a 6v and a 6v. Right, so that could be our answer right there. On the difference of squares like this, it makes sense not to rearrange it. But on one like this, you may find yourself being able to easily more recognize this one as a easier problem if you were to rearrange it like this. Right, if there's no negative signs, it's easy to rearrange things, and then we could start the factoring process. But on this one here, look out for a greatest common factor. There's going to be one. See if you can't spot that, and then continue on to finish solving that problem.